All right, let's smash this. In the next few minutes, we're going to absolutely master the electrolysis required practical. This is your rapid-fire revision guide, giving you everything, and I mean everything you need to walk into that GCSE chemistry exam feeling like a boss.
So, here's our game plan. We're going to cover 5 key things. We'll start with the absolute basics, the foundation. Then we'll get into the rules for predicting what you'll actually make. After that, we'll walk through the practical method itself, figure out how to analyze your results, and then, the big one, how to absolutely ace those exam questions.
Right, Section 1, the foundation. Look, before we can even think about doing the experiment, we need to be speaking the right language. This is all about nailing that essential vocab.
So what on earth is electrolysis? At its heart, it's actually a pretty simple idea. The name kind of gives it away, right? Electro for electricity and lysis, which just means to split up. So we're using electricity to split up or decompose an ionic compound. The key detail, the one you can't forget, is that the compound has to be molten or dissolved. We call that an electrolyte.
And that brings us to these 5 terms that you have got to know. The electrolyte is our substance, and it only works because when it's molten or dissolved, its ions, those are the charged particles, are free to move around and carry the charge. The electrodes are the rods we stick into the electrolyte, and they're where all the action, all the splitting up, really happen.
Now, it is super easy to mix up the electrodes, but listen, here's a little trick that will guarantee you never lose a mark on this again. Just remember the word panic. Positive anode, negative is cathode. Simple, effective, done.
Section 2, predicting the products. Okay, so we know the key players, we know the lingo. Now let's get into the rules of the game. How do we actually predict what's going to be made at each electrode? This is such a core skill for your exam.
Okay, so here's the twist. If you melt a compound, it's easy. The positive metal ion goes to the negative cathode, and the negative non-metal ion goes to the positive anode. But for this practical, we're using aqueous solutions. That means water's in the mix, and water also splits up into ions, H+ and OH-. This means you've got competition at the electrodes. So, who wins?
We need rules. And luckily, they're pretty simple. At the negative cathode, it's a battle between the metal ion and the hydrogen ion. And the rule is, the least reactive one wins. So you just ask yourself, is the metal more reactive than hydrogen? If the answer is yes, then hydrogen gas is made. If no, the metal is made. Simple. Over at the positive anode, it's a fight between the non-metal ion and the hydroxide ion. The rule here is even simpler. If you have halide ions, that's your chloride, bromide, or iodide, then you make the halogen. If you have no halides, oxygen is produced. That's it. Just memorize those 2 rules.
Let's see these rules in action, shall we? Okay, copper sulfate. At the cathode, copper is less reactive than hydrogen, so ding, 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 copper metal is produced. At the anode, sulfate is not a halide, so oxygen is what you get. Now for sodium chloride. At the cathode, sodium is way more reactive than hydrogen, so hydrogen gas wins. At the anode, chloride is a halide, so chlorine gas is produced. See, it's just a simple, logical process.
Okay, theory sorted. Let's move on to the practical itself. How do we actually set this all up in the lab to see what happens, just like the AQA spec wants us to?
Here's your kit list. The really key things to remember are the inert electrodes, which are usually graphite. Inert is a key word. It just means they won't react with anything, so they don't mess up our results. And of course, non-negotiable, eye protection on at all times.
The method itself is beautifully simple. You pour your solution in, you put your electrodes in, make absolutely sure they don't touch or you'll short the circuit, connect it all up, flick the switch, and watch. You're looking for stuff like bubbles of gas or maybe a solid coating forming on one of the electrodes.
Now, seeing bubbles is a great start, but for a top-level chemistry answer, that's not going to cut it. You have to be able to identify what those bubbles are. This is all about being a chemical detective and gathering the evidence. This table right here, this is pure gold for your revision. You need to know these 3 tests and their positive results off by heart. For hydrogen, a lit splint gives that classic squeaky pop. For oxygen, a glowing splint will relight. And for chlorine, damp blue litmus paper gets bleached and turns white. Know the test, know the result, no excuses.
So, this is the crucial part, isn't it? How do we take all this amazing knowledge and turn it into maximum marks in that exam? Let's bring it all together and figure out what those examiners are really looking for.
This is basically your checklist for a perfect answer. You have to predict the products at the anode and the cathode. You have to justify it using the rules we just learned. You have to say what you would see, the observation. And if a gas is made, you must state the test and the result. And for all you higher tier students, you also need to be able to write those balanced half equations.
Okay, let's look at a classic exam question. A student investigates the electrolysis of aqueous potassium bromide. Predict the products, justify your answers. Right, take a second. Don't panic. Think about our rules. At the negative cathode, it's potassium versus hydrogen. At the positive anode, it's bromide versus hydroxide. What's going to happen?
And that's pretty much everything. You now have the complete toolkit, you've got the prediction rules, you know the method, and you've got the test to prove what you've made. So my final question to you is, looking at that potassium bromide problem, how would you structure your answer to get every single mark available? Go on, pause this and give it a try. You've totally got this.